Okay, so this is the equation we were looking at today to work out delta H for our experiment. So what we need is the overall delta H, and we were working that out using the delta H of the water and the delta H of the vessel. So as we mentioned in class, we've got the delta H of the water, which is the same as the negative mCAT equation for the water, and the delta H for the vessel, which is the same as the negative mCAT for the vessel. So the delta H for the water is fairly easy. It's the same way that we normally do it. Okay, we use the mass of water from the volume that we put into the can. We use 4.18 joules per gram per Kelvin, and we use temperature final minus temperature initial. Okay, so you measured that and write that down in your results table. Alright, so then we move on to the second part, which is the vessel. Now we've got to do something a little different here. We've got the mass of the copper can, which you measured as part of the experiment. You're going to need to look up the specific heat capacity for copper. Now the key thing here is to check the units, because we measured the mass of the copper can in grams. So you need to look for the specific heat capacity of copper in joules per gram per Kelvin or per Celsius. Alright, now then you need to assume, this is an assumption within the equation, that the water temperature final minus temperature initial is going to be the same for the can as it was for the water. Now, another key thing here is that each run gives the delta H for the mass of fuel burnt. Alright, so to work out the mass of fuel burnt for a particular run, you have to look at that run's initial mass, take away the final mass. And that is going to be different for each run. So you need to work out the delta H for each of these for each run. So you're going to end up with 9 different delta H values. Okay, and I'll show you how to do that on Excel.
So using Excel is very good if you're doing a whole bunch of calculations that are pretty much the same. So if we have a look at this, now I've broken this simply into 2 sets of tables simply because I wanted to show you on the screen, and it's hard to do that if it's going off the screen. So it's okay if your table keeps going this way, that's fine. So for trial 1, if you go into trial 1, what you want is the change in mass. So you want the mass initial, alright, and the mass final. Okay, so we go equals mass initial, subtract mass final, enter. Once you've got that, you can then just pull it down and it'll calculate the others because it's dragged the equation through. Temperature change, same deal here. So up to temperature final, so we go equals temperature final, take away temperature initial, enter, and once again we can just simply drag that down. Now the equation for delta H, which I've put in blue at the top of the Excel screen, for the water, so it's negative mCAT. We're not going to worry about the negatives at the moment. We're just going to make the formula. So we go equals, now where's our mass? Our mass I've put down here. Our mass of water is 100 grams. Equals 100. Now because you don't want that one to change when you drag it down, you actually need to put dollar signs, which tells it not to move. That one, times, we use an asterisk for times in Excel. This one, our specific heat capacity for water. Once again, we don't want that one to move when we drag it down, so we've got to put the dollar signs in front of the letter and the number of the cell. Okay, and then once again, times by our delta t. Now our delta t we do want to move as we drag this equation down. So what we've got here, what this is saying is, what this equation is saying is we have this one, don't move it, times by this one, don't move it, times by this one. We do want this to move down as we drag it down, so we don't put the dollar signs. We hit enter, then we can simply drag that down. Alright, you can do all this by hand as well, you don't have to use Excel. Delta H of the vessel, once again we've got negative mCAT, we're not going to worry about the negatives, we'll just do equals the mass of the vessel, I've made the mass of this vessel up, equals this one. That's not changing as we are dragging the equation down the cell, so we have to tell that not to change. Times by our specific heat capacity for copper, once again that doesn't change as we drag the equation down, so we have to put the dollar signs in. Then we need to multiply it by the change in temperature again. Alright, so here's the change in temperature, and we do want that to change as we drag this equation down. So once again we drag this down. Now you'll notice here that I don't have consistent numbers of decimal places. You can format the number of decimal places by going to Format Cells, Number, and just click the appropriate number of decimal places. Okay, so once I've got my delta H for the water and for the vessel, then I can simply add those together. So equals, click that cell, then I'm going to add it to this cell, enter, and I can drag those numbers down and the equation will drag down. So that's the quick way of doing equations in Excel. Now, because of the way this is set up, you can then go through and do the same sorts of equations across here. If you're ever unsure if your equation is pointing to the right points or you're getting strange numbers, click into the cell and click into the equation in the bar up here, and it will show you with the colours where the numbers are coming from. Okay, and if you're happy with that, you can just hit enter again. We're going to work out the delta H per gram of the alcohol now. What I've done is I've put the total delta H in red for each of the trials, just simply so it's easier to read. Now obviously what we're doing here is dividing the total delta H by the number of grams of fuel that was burnt, which we've already worked out in our calculations. They're over here. So it's simply using one to divide by the other. So using Excel, we go equals the total delta H divided by the change in mass. Okay, and we can just once again click and drag that down. We can do it for trial 2, so trial 2 is over here, so the total delta H over the change in mass of fuel. Okay, and trial 3, so we've got the total delta H divided by the mass of fuel burnt. Okay. Now, as you can see with these numbers, we've got a fairly broad range. So what we're going to do is we're going to average these. Now, there is an average function in Excel, which is nice and easy to use. If you double click on average here, and we'll move that out of the way so you can see, it's already picked up the fact that we want to average the 3 in front, which is what we want to do. We hit enter, and we can just pull that down as well. Pop that away. So we now have our average total delta H per gram of the alkanol. Now I am just going to make that a bit easier to read by formatting the numbers just down to one decimal place would be fine, so that it's a bit easier to read. So we can see that the average total delta H per gram of methanol is 3,470.8 joules. So now we're working out the number of moles of the alkanol that was burnt. Now obviously we're using our N equals little m on big M equation. So we need to go and find our mass of mole fuel burnt. So it's over here for this one, for trial 1, equals this one divided by our molecular mass, which I've worked out earlier and popped over here. Enter. Now because of the way I've put the molecular mass running down the same way that I have for the alkanols, I can actually just click and drag that. Okay, or you could do it individually. Now, so for this one, we are doing trial 2, and once again over the molecular mass and drag it down. And then for the final trial 3, the mass divided by the molecular mass and drag it down. So now we have the moles of each of the alkanols burnt in the 9 trials. So now to work out the joules per mole of delta H, what we have to do is have our total delta H and divide it by the number of moles. So total delta H divide by number of moles, enter, and we can drag that down. Okay, similar thing here. Whoops. Equals delta H divide by number of moles, enter, drag it down. Delta H divide by number of moles, enter, and drag it down. Now you can see that we're getting quite large numbers, so it would make sense to change this to kilojoules per mole. We'll do that after we average it. So once again we're averaging, so we go up to the formula bar and click average. Hopefully it's already picked it up for us. Oh, it hasn't this time, so we'll just need to select the range and press enter. Let's try that again. There we go, that's better. Okay, enter, and we can just pull that through as well. Okay, close that out of the way. Okay, so now we have our average delta H in joules per mole. So what we would like is probably average delta H in kilojoules per mole, because that would make more sense given those numbers. So obviously we are dividing this by 1,000 to get the kilojoules per mole and run it down. We can fix up the borders and just so that we can read it a little better, we can also format that to 1 decimal place. Okay, so here we now have our average delta H in kilojoules per mole. So we've managed to calculate our average delta H in joules per mole and in joules per gram and kilojoules per mole. Okay, so that's a lot of calculations, and as I said, when you're doing a lot of calculations like this, Excel is quite good because you don't have to do things over and over again, but you do need to check that you've got your equations set up correctly and that they'll pull through correctly.